Welcome to this episode of the Structural Engineering Channel podcast, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives.
I'm your co-host, Matt McCardle. I'm a licensed engineer at DCI Engineers, practicing on structural projects in California with an undergraduate degree from Cal Poly Pomona and a master's degree in structural engineering from UC San Diego.
And I am your co-host, Alexis Clark. I work in Hilti's North American headquarters as the product manager for our chemical anchoring portfolio in the US and Canada. I'm a licensed professional engineer in Texas. I received my bachelor's in civil engineering from UT Austin, and I'm currently an MBA candidate at Auburn. In this episode, we are very excited to be talking to three individuals that are involved in a seismic upgrade to a heritage-designated world-recognizable work of architecture, the Museum of Anthropology, or MOA, in Canada. The individuals we have on are Nick Milkovich, the principal at Nick Milkovich Architects Incorporated, who is also the principal architect for this upgrade. Nick Milkovich was born and educated in Vancouver. He established Nick Milkovich Architects in 1991. Since its inception, the firm has created a broad portfolio including large planning and urban design projects, large-scale public buildings, small and medium-scale residential developments, and single-family residences in North America and Asia. Alitha Utamati, the project manager at the University of British Columbia and for the Great Hall Renewal Project.
Alitha started her career in Brazil, working in commercial and large-scale hotel renovation projects. In 2013, she moved to Canada to pursue her Master's of Engineering in Project and Construction Management at UBC. Before joining Project Services, Alitha coordinated research projects for the Center of Interactive Research on Sustainability. She also has a background in architecture and urban planning and is a certified project management professional, or PMP.
And Eric Karsh, a structural engineer and principal at Equilibrium Consulting Incorporated and a leader in timber engineering and construction. Eric began his structural consulting career in Ottawa in 1987 with AAR Limited, designers of the Toronto Sky Dome. Eric has since been involved in hundreds of projects of all types and scale. Always sensitive to the efficient design and careful detailing, Eric has extensive experience in all common building materials. Since his arrival in British Columbia in 1993, however, Eric has become a leader in timber engineering and construction and is invited to lecture on the subject around the world. Eric is co-author of the widely publicized Case for Tall Wood study with architect Michael Green, which introduces a solid wood panel solution to practically and cost-effectively achieve heights of 20 to 30 stories in seismic zones such as Vancouver. Tall wood has spurred global discussions on the topic of timber high-rise construction and has been featured by organizations such as CNN, The Economist, National Geographic, and in Michael's TED Talk in 2013. Now let's jump into our conversation of the week. Alitha, Nick, and Eric, thank you so much for joining us on the show.
Thanks for having us.
Happy to be here.
Likewise.
We are so glad to have you with us here today. So in the most recent round of UBC building evaluations, it was identified that the Great Hall, as part of the Museum of Anthropology, is one of the spaces that is at the greatest seismic risk. I believe that the MOA has already begun preparations for a rebuild of its iconic Great Hall that will upgrade the resiliency of the space and protect its collection in the event of a major earthquake. Each of you have spent the time to join us today, and you each have a very specific role in this retrofit process. Would you guys each please shortly tell us a little bit about what your job entails as it pertains to this project? Eric, we can start with you.
Sure. So the Great Hall is, of course, a very iconic and very important heritage building in Canada. It's designed by the late Arthur Erickson, and in my understanding, the Great Hall certainly is one of his most important work. Architecturally, a very elegant, very beautiful structure. However, from a seismic standpoint, both because it was designed in the 80s, but also because of its form as a very tall, very slender moment frame structure, is very susceptible to seismic forces. And of course, the fact that it's wrapped in glass makes the issue an even greater challenge. So my job was to find a way to preserve the structure while bringing it up to code without changing the architecture, which is in essence quite susceptible to seismic forces. So I think we'll get to talk about how we went around to doing that a little bit later.
Aletha, would you like to share with us how you contribute to this project?
Sure. So my role is the project manager role in this project. My role as the project manager is to oversee all phases of the project. So since the planning, inception of the project, through design, construction, and finally commissioning and handover to the occupants. And so throughout all of those phases, I work to ensure that the project's objectives, timeline, and budget are met. On my day-to-day, I act as a university representative, and I facilitate the work between our consultants who are here today, contractors, museum, and other stakeholders, internal and external to UBC.
Nick?
Yeah, we're the prime consultant on the job, so we organized a full consulting team. But other than that, our main work is really to as Eric mentioned, the recognized architectural work and the heritage structure, our main role is really to keep that intact as much as we can, with as little interference as possible in all the very evident parts of the building. And that beyond that, I think we're just it's our role is primarily architectural. It's a lot of the detailing that deals with the structural issues that are visible that we have to take care of and try to, what we mentioned when we started the job is we would like that when we leave the job, it should feel as if we were never there.
I love that. That's a beautiful way to state the objective of this project.
Yeah.
Perfect. Aletha, can you tell us a little bit more about why the University of British Columbia, or UBC, is undertaking this project?
Yeah, so as you mentioned at the top of the introduction, UBC has decided to address the Great Hall because it is considered one of the high-risk areas on campus. This was discovered through a planning that UBC has been doing, which is to increase the resilience of the whole campus. So this was done through a comprehensive evaluation of seismic risk across all buildings, utilities, and assets on the campus. And it's really meant to prepare UBC for a major seismic event. So this study was completed through a collaboration between industry experts, UBC's seismic researchers, and they developed a very detailed model for assessment. And they take into consideration very specific conditions of the Vancouver campus and are creating an action plan. Out of this assessment resulted the knowledge that the Great Hall is a very high, at very high risk seismically. So it was prioritized for upgrade. One of the interesting aspects of this project is that the seismic upgrade is not only focused on the life safety, but it's also intended to preserve the museum's invaluable collection. We always say that people can get away once an earthquake hits, but objects can't. So we need to protect both people and objects, which is beyond what you would normally do just by building code. So we're aiming for a very high structural performance. But on the other hand, as Nick mentioned, we want to do this project in a way that once we leave, it feels like we were never there. So we need to protect the very important heritage value of the building. And it comes with very character-defining architectural elements. And this, I think, presented a very interesting challenge for both Eric and Nick that had to find ways to make this work with the current technology, but keeping the same look and feel of the space.
I have to just say I love the way you explain the entire project, and I'm really amazed that the university is already putting not only resiliency as a priority, but putting money into it, and they're putting the effort behind the initiative. Just from a curiosity standpoint, where did this need for resiliency come from? Was this pushed through the university itself? Was it stakeholders? Who was really the driver behind this effort?
So this is really an ongoing effort. It's been in place since the 90s. But recently, in the last 5 years, it has actually gained a lot of strength on campus. We've seen what has happened with major earthquakes in other parts of the world, and we're learning from it. This comes from the realization that the university can't afford to shut down for an extended period of time following a major event. If that happened, then means that all of our researchers and all of our funding would go elsewhere. So we need to be able to come back in operation quite quickly after an earthquake. So the study really focuses on how long does it take to be operational again. That doesn't mean that we're going to be fully operational as we are today. Of course, we'll have to adapt, as we've all adapted with COVID and other situations, but it's keeping a minimum function so that we don't lose momentum with the university.
Yeah, thanks, Letha. I know that's, coming from the engineering background, it's always good to hear about that, because yes, like per code, it is kind of the bare minimum, but when you work with clients that do want that extra effort and they understand the other aspects of resiliency, yes, it's not just earthquake, but are you operational? Are you basically protecting, like in your case, I'm sure the artifacts and all the unique items in the museum, you're protecting them too, and not just, I kind of think of it similar to hospitals, where yes, it may still be operational, but what if a large shaking happens? What happens to all of the expensive equipment that's probably more expensive than the building itself, that's not really taken into the code unless you kind of get more into this resiliency. So it's great that UBC has taken an interest in that and to put money towards that. Nick, I wanted to talk about, because for this project, you've worked with the late Arthur Erickson, an iconic Vancouver architect. And from my understanding, you worked on this project with him, when you were still young. Could you kind of go into what that experience was, what it meant to you, and how it affected your perspective on this project? Because I feel like it's kind of probably maybe a legacy project for you. So could you go more into that?
Well, his office was very interesting place. It was like the continuation of school. Even though he's a name architect and all that, yet his studio, he wasn't autocratic. His studio was very explorative, where anyone can come up with ideas that can be discussed and debated and implemented if they seem to work. So that was great, a great place for a young guy. I started there right after school. And he was, actually, Arthur was one of my second year architecture teachers. And so that was the foundation of the office. So you felt comfortable in tossing things around and playing with them. And he wanted that. He wanted people to come up with ideas to discuss. So the early part of the building, I was a young guy there. I was just out of school a couple of years or so. And, typically what you used to do, we used to build a lot of physical study models. And that's what the young folks tend to do, and I remember one day Arthur came by and he said, could you build this a floor plan for this building model, to scale? And it was really the procession of the museum from the entry down to the pond, or the inlet as it was called. It was a series of graded platforms, following the slope. And the whole idea of the museum, in a way, the concept behind it was that it was inspired by a photograph that Arthur saw of actually in Haida village up on Anthony Island. And it was really, most of the villages were right by the water, just off the beach. So this, the movement through the museum represents that movement of moving from the forest across the beach to the water. And and you know, the light becomes greater and more open as you go through the building. So that was the whole storyline of it. And the next model, you know, and actually all the exhibits, sort of potential exhibits, were noted on his little sketch drawing where they might be on the path. So then the rest of the job was, how do you cover it? And the next model he asked me to take a look at was the structural frame that Eric's saving now. And that was just a study model to see the proportions and all that. And Arthur was really very interested in proportional experiences of whatever, you know. So that was the fun part. But and then it continued. I mean, you know, we played together till the end. You know, it lasted for about 40 years, even though I had my own practice.
Oh, that's great. Whenever I'm not an architect, obviously, but you know, it's always cool to see what the challenges that the architects are trying to solve or try to envision for their clients. Was there anything particular with this, or some of the challenges for this project that you were trying to maybe preserve the heritage in some way, kind of the architectural challenges that you went through and how you solved them for this project? I'm always curious about, you know, what the architects are trying to think and try to solve, and for us, how the structure implements into that too.
You mean of the restoration portion now, the seismic upgrade?
Yes, for this seismic upgrade project.
Well, it's kind of, it's there. I mean, it's been around, and there's a lot of people are looking at this. You know, there are a lot of stakeholders, the university, the museum people, you know, Arthur Erickson Foundation that oversees a lot of his works, and you know, to make sure they're not violated in any great way. But so, and then there's the Musqueam, who are, you know, the building sits on their lands, and they have a particular interest in the landscape or the forests around it and how that's handled. So anyone that, you know, and there are a lot of people that are just purely interested in the building, you know, so you hear from a lot of folks, which is good.
Excellent. Thank you for that explanation. It's nice to hear a little bit more about how the actual shape comes together, especially for our listeners who can't necessarily be looking at a picture of the space while they're sitting in their cars and listening, or right now sitting at home and listening. Wonderful. So Eric, I read a little bit in the article that you guys shared with us that some of those planned seismic upgrades that you have will be achieved using base isolation technology and vertical glass upgrades. Can you tell us a little bit more about what this process looks like and some of the challenges that you faced?
Right. So for the reasons that Nick explained, the structure, of course, is very open and very light. I think the intent was that you felt like you were outside, even though you were inside a building. So as a result, the structural expression is a very tall, very slender moment frame, which happens to be made out of concrete, so it's heavy, and it's wrapped in glass, which means that seismically, this is a very susceptible structure. And being as important as it is, and being heritage, the traditional seismic upgrade methods were not an option, because the introduction of additional elements or braces could not be hidden anywhere. And the structure is an integral part of the architecture. So anything you do to it impacts the original work, which was something that we were committed to avoid. So if you cannot improve the structure as it is in any way, then the only thing you can do, or certainly the obvious thing that you would want to do, is to move the structure to a place that has little or no seismic load. And this is the concept behind base isolation. You disconnect the building from the ground, basically put it on a bed of jello, and reduce the loads on the structure that way. So we started with that. We did an analysis of the existing structure with base isolation. and found that while we could improve the likelihood that the structure would survive very significantly, we still had too much movement, and it was very likely that the structure would get damaged, and that the glass that surrounded the building, of course, would get damaged because of the significant movement that we expected. So we came to the realization that the only way that we could really make this structure safe and improve the performance of the envelope in particular was to rebuild it, and to, while keeping exactly the same structure, rebuild it in a way that would be a lot more resilient and would have a much better performance, to ensure that we could in fact preserve the structure through a design earthquake, but also the envelope and the contents. So we still have a base isolation approach, but we're having to rebuild it to actually meet code requirements. But in the end, the structure will be exactly the same. It'll just be detailed differently and designed to code.
Very interesting. I have to say really quickly, I've never heard a structural engineer use the term bed of jello for any kind of foundation. And I wonder if we have geotechnical engineers who are freaking out right now, but I love the terminology.
Right. So it's like lifting the building off the ground and moving it to Winnipeg, where seismic loads are low.
Our Canadian listeners will get that one. But for those of you who are not sure where Winnipeg is within the entire country of Canada, it is in Ottawa, and it is just kind of due north, maybe northwest of Toronto.
Right.
No.
In the prairies, in the middle.
It's in the middle. It's just
moving it to Nebraska.
Yeah.
Okay, there we go. Thank you. That is very helpful for our U.S. listeners. Go, just keep, if you're in Nebraska, just keep walking north.
Yeah.
Thank you.
So Eric, just so for my understanding, so instead of, redoing the whole entire existing lateral system, it looks like you guys put in a base isolation system and rebuilt the glass facade so they can take those seismic loads. Is that pretty much what you guys did?
Well, because the structure is so tall and flexible, we do expect in a seismic event, even with the base isolation, that it will sway significantly. So the glass, which is single pane structural glass, wasn't initially detailed to accommodate any move. Well, certainly not nearly as much movement as we would anticipate. So the rebuild gave us the opportunity to redesign the interface between the glass panels and the structure to ensure that the anticipated seismic movements would not likely cause any damage to the glass. So that was an opportunity that we wouldn't have had if we had not done the rebuild.
And so you're putting base isolations under an existing building, is that right? So what are the construction challenges there? Maybe Eric or Alitha, I know that's probably a big construction challenge there. Can you go talk more a little bit about that?
Well, we're actually rebuilding the structure. So in this case, we will have access to the foundations directly from once we've taken off or taken down the existing structure. But initially, we had planned to build a crawl space with the base isolation system underneath the existing structure. So we would have had to do that one column at a time using shoring in the interim. And basically, we would have had to go under each column, cut the column between the ground plane and the footing to introduce an isolator, and then build a new floor slab to tie all the columns and isolators together. And we were planning to do that without taking down the structure. So that would have been more complex. But now that we're rebuilding the frames, it's going to be a traditional construction process, essentially.
Gotcha. And I wanted to get more into the construction stuff too, because I know for me, and probably most of our listeners too, are familiar with the structural engineering, but I know from the project management standpoint, uh, like you guys were saying, mentioning that, you don't want to interrupt the museum as much as possible. Aletha, can you go into maybe some of the challenges of project management and scheduling? I'm sure, uh, I've worked with project managers before, and I know it's a complex job, especially with all the different clients you have to go through and all the scheduling and meeting the needs of the existing place. I'm sure there were some challenges. Can you go over some of those, how you guys solve those?
Yes, of course. So yes, definitely a challenge for us to work with the museum. And we've been working really hard and collaborating with the museum, construction manager, consultants, to do it in a way that minimizes this impact, because we know we're going to impact the museum. The Great Hall is a great, it's an important attraction for the museum. It draws a lot of people because of its architectural significance. So we know that by closing it, we'll be impacting the museum. So we're trying to keep the schedule overall at a minimum as possible. And also work with them to realize ahead of time what other those impacts might be. We've identified some key strategies to do that in this preliminary stage. So for instance, we have ongoing vibration monitoring to ensure the safety of the very delicate artifacts, because this is not a gentle construction process. We're essentially taking down the whole building, the whole section of the building, and rebuilding it while the other sections are still occupied. And so we want to make sure that any vibrations coming from the demolition process don't affect those very delicate artifacts that we're trying to preserve. We've also been concerned with security because of the value of the objects in the museum. So we done an external review to ensure the collection would be protected. There will also need to relocate several building services that ran through the area that's going to now be demolished, but served other building areas. One of the critical items in these relocations was, it still is ongoing, the HVAC relocation. This system maintains critical environmental conditions for the artifacts, and we can't disrupt it for too long of a time. So we are planning and working with construction manager and trades to do the work in very quick downtime for the system, and to have measures in place to mitigate those environmental conditions if needed. So we have a plan A and a plan B and all of those safeties in place if need be. Another big strategy that we've adopted is to just build an access road. So the Great Hall area is close to the landscaped area towards the back of the museum. And that creates a very complicated access to the construction site. If we were not able to build this access road, we would have to go through the museum, especially where the public access the museum. So that was off the table. And so we decided to build this access road to go straight into the Great Hall. And it's currently located where the reflecting pond used to be. So we had to drain the pond and state the site staging area, the access road, and will all be removed at the end of the project. This is only a temporary measure to allow us to access the site. And at the end, we'll have to do a landscape remediation. This area, as Nick mentioned, is a very important area for Musqueam. So we are working with them to make sure that we reinstate it in a way that's respectful of the heritage aspects of the land.
Yeah, it's always fascinating, especially with this type of project where there's so many stakeholders, and there's a lot of things that are important to who you're talking to, like you're mentioning. And just my last follow-up question to that, since I had this on my notes, in the Great Hall there was a massive wooden carvings and poles that reside in the Great Hall. How did you plan to protect those carvings during construction? Because that's one of my main points that I wanted to get to also.
Yeah. So as I mentioned, it's not a gentle construction process. We will have to have very heavy machinery around for both the demolition and the precast construction. So there wasn't really a way to protect them in place. The only option was to move the totem poles and other artifacts to a adjacent gallery. So we have worked with a specialized moving company that has experience with museum and very delicate objects to lower the totem poles. There are some, more than 20 massive carvings. They had to bring in very heavy equipment, but with very delicate crew to operate it, and under the very detailed supervision of museum's curator. She never left the site while they were doing the work. And so all of those totem poles were lowered, placed, positioned horizontally, and then moved into the adjacent gallery. And they are now resting there, waiting for the project to be completed, and they can be moved back into position. The curators will also take the opportunity while the totem poles are there in this unique position. They typically are not accessible to them. So now that they are accessible, they'll take the opportunity to do maintenance and curatorial work with the poles, and also to study them and to be able to engineer the new mounts for the poles. The existing mounts cannot be reused, and we're not sure if they could accommodate all the movement that we're introducing in the building. But at the same time, you need to study carefully each pole and make sure that you can attach it to the pole in a way that it's safe to the artifact. So it's a hand-in-hand work between the curator and a dedicated structural engineer that will be designing these mounts. Another interesting thing to mention is that it's not only an engineering, not only a moving exercise. This work has to have a lot of cultural sensitivity attached to it. And we were fortunate that we were able to have members of First Nations community and other museums witness the lowering of the totem pole, take part in the process. And we had people in person and we had people remotely, given all the pandemic conditions. So we're fortunate to have the support of those communities too.
Holy man. I just have to really quickly just step back and say, you three are amazing. I don't know how you're doing this project. I mean, reading through the article was pretty impressive, and just, understanding all the different complex facets of this job. I know every structural engineer deals with a lot of complexity on their job site, regardless of what it looks like. But not only are we doing a rehabilitation or retrofit of sorts, it's a seismic retrofit. So we're taking a glass and timber structure. We're trying to keep the integrity of this amazing architect's vision in the structure itself and in the building, but make it stronger so it can withstand an earthquake event. And also, you're walking on eggshells the entire time, because everything inside that building isn't just something that's valuable, it's priceless. This is the Museum of Anthropology. You can't replace these artifacts. My mind is blown. I'm just so impressed with the three of you. And this is an incredibly intimidating challenge from my perspective. And I'm just blown away that you guys have spent the time with us. This is awesome.
Yeah, and just getting the buy-in too from everyone. I'm sure there's a lot of stakeholders that are,
oh my goodness,
like the indigenous people too. That's really impressive.
Absolutely.
A lot of communication.
Yes. This might be the ultimate example of communication.
Exactly.
That is awesome. Okay, excellent. So I have a follow-up question for Nick. So I'm digging a little bit into the technical here. So I'm excited that you're going to share this with us. Can you tell us a little bit about the differential seismic movement between the Great Hall and the rest of the museum? And how is that going to influence this already very confusing construction process?
Yeah, well, it all started with Eric's proposition of base isolation. And what that does, it really dampens the movement of the earth on the structure itself. And, but the only part of the museum that's being isolated is the Great Hall. So you'll have differential movement between the Great Hall and the rest of the building, and also the surrounding grade. So we had to devise connectors that would take care of that movement, both in the horizontal plane, vertical, horizontal floor, roof, ceilings, and vertical, where the buildings touch vertically. And also that goes right through the roofing membrane too. So all that had to have that flexibility so it can move. And I think the movement is, correct me if I'm wrong, Eric, up to, this very severe earthquake is about 1 foot 2 inches differential. And so the building has to move that much and be able to accept that without not a whole lot of damage. But also our drive was to not see that movement, not have it apparent. It's not, even the floor plates will be covered with carpets, and they're designed to move so that they'll pop out of the place, out of the way, so the building can move. But then it's easy to repair. You won't even know they're there because there's just be a line in the floor, in the carpet. That's about it. The vertical ones were more difficult because some of it, or a lot of it, was really glass to concrete, where we have glazing that was detailed to just, into a reveal into concrete walls. So that one was quite tricky and to handle. And it was quite very challenging. And then the roof one, because you have all the roofing membranes and everything that had to bridge the gap somehow. And I think there are about 1 million details, that were produced for that. Well, not quite, but it is a lot. There's a detailed book that covers all that for the builders. And the other one is I think the difference. I'm trying to be engineer here a little bit, Eric, but I think the movement is just that it moves. But it moves in a different period. I think it's up to 3 seconds to do that amount of movement. So it doesn't get rattled around. So that really helps the placement of the artifacts and the securing of the artifacts and the glass wall. It's up to 50 feet high. And so that's within the glass design. You can also, there was a lot allowance for movement between the individual sheets of glass through the silicone. It's very interesting. It's engineering art.
Yeah, you would have.
That's
you would have made
beautiful.
a fine engineer, Nick.
Pardon?
You would have made a fine engineer.
We'll take you. You could use a new career change, right?
Yeah, no. I'm not disciplined enough.
Yeah,
I love it.
The result of base isolation is that you're of course softening the interface between the building and the ground, and the result of that is that instead of having the ground accelerate the building very quickly because they're disconnected, the building ends up moving very, very slowly and over a larger distance though. So that's what makes the need for those larger joints to be introduced. So the building moves very, very slowly instead of vibrating very quickly as it normally would if it was connected to the ground.
Eric, I have one final question for you. Many of our listeners are structural engineering professionals who are building their careers. You have clearly built a really well-known expertise in timber engineering and construction. My question to you is, what does it take to become an expert on a specific design process or material for a structural engineering professional? And what advice can you give to those listeners who are maybe eager to do that in their own careers?
Well, I had the opportunity to work on timber projects later in my career. I did not actually study timber engineering. Maybe you didn't want to hear that, Nick. I really learned timber engineering later on in my career in the field. If you know that you love a certain topic or that you really want to specialize in something, of course, you should take the opportunity to get the basics through your studies. But in much in the way that Nick described his experience with Arthur Erickson in a studio type environment where you learn on the job, this is really how we run our office as well. And we have developed our timber expertise one project at a time over a period of 22 or 23 years now. And, you know, the business of engineering is a cautious one. You don't want to take risks that you cannot fully control. So, but we've always been interested in innovation, and we've always tried to add a little bit of innovation to each of our projects. And as you do that over a couple of decades, you certainly accumulate a lot of knowledge. And again, you can get, you know, a good basic understanding of your materials and of engineering principles in school. But if you are interested in a certain area of engineering, you really should try your best to find an office environment that will continue to teach you that expertise hands-on. Because really, at the end of the day, you really learn that trade, as so many trades are learned, you know, by doing it. So, so this is, you know, how we run our office. We try to give opportunities to young engineers to you know, get hands-on experience from day one, and so choosing the right office environment for you will be a big part of your career path. So I would encourage anyone who is passionate about something to be patient and find the right professional opportunity as early as possible in your career, because ultimately that will define the trajectory that you follow.
Thanks so much for that advice, Nick. Eric. Eric, Nick, and Alita, I did want to thank all of you for coming on, especially because what's unique about this one is we got all these different perspectives, not just from the structural engineer, but from the architect and from the project management side as well. And I think it's going to be really valuable to our listeners, because sometimes we're just focused on structural engineering and you don't see that whole entire picture of, hey, why are you even doing this building? It's, you know, it's not just the numbers, it's see what it's doing for the people and trying to achieve what that they can eventually use and enjoy when it's complete. So I really just want to thank you all.
Thank you. It was a pleasure.
Thank you. Thank you. It was fun.
Yeah. Thank you for having us.
We hope you enjoyed today's episode. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, which is episode number 42, as well as links to any of the resources, websites, or books mentioned during the episode. Don't forget to subscribe on Apple Podcasts or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.